A beam suddenly starts cracking on a construction site, but the real question engineers ask is, what forces are acting on it? To solve this mystery, engineers use a powerful tool in mechanics of solids. A free body diagram means isolating an object and showing all forces acting on it. Every arrow represents a force: gravity, reactions from supports or external loads. Even a simple concrete block sitting on the ground experiences multiple forces. The block pushes down with its weight. The ground pushes back with an equal reaction. When forces are balanced, the structure stays stable. In engineering terms, the sum of all forces must equal zero. Let's analyze a beam carrying a heavy load. First step, isolate the beam from the structure. Second step, draw all external forces. Third step, apply equilibrium equations. This helps engineers calculate unknown forces inside structures. Engineers use free body diagrams to design bridges. They also analyze cranes, beams, trusses, and foundations. Every member of a truss has forces that must be calculated. If engineers skip the free body diagram, forces may be misunderstood, and wrong force calculations can lead to structural failure. That's why every structural calculation starts with a clear diagram. Engineers confirm designs using structural testing. Beams and materials are tested under controlled loads. In load testing, engineers measure deflection and reaction forces. These measurements confirm whether theoretical force calculations are correct. Regular inspection ensures forces remain within safe limits. Behind every massive structure, engineers first study the forces, and it all begins with one simple sketch: the free body diagram.